Okay, good morning, everybody, or good day, no? Uh, Welcome to Powerhouse, Marina's Powerhouse Team Review and Training Center. So today we will take up, no, electrical principles, no. So this is a pre-lecture, no, being given by Marina's Powerhouse Team Review and Training Center, no. Uh, Good day to everybody, no, to all Filipinos watching, and if we have our foreign friends, no, non-Filipinos, no, good day to you, no. So this is our day one of our, we call this as study electrical engineering, no. We say restudy because we will restudy electrical engineering topics, no, to the most detailed way, no, and we see to it that every topic will be discussed thoroughly, no. We have this topic about electrical engineering. We have a time frame for more than 1 year to discuss all the topics. Please highlight myself there. Okay. So, okay. Once again, good day, everybody. Okay, so our topic for today is about electrical principles. No, this is a series of lectures, no, being conducted by Marinay's Powerhouse Team Review and Training Center. By the way, my name is Engineer Reggie Marinay from the Philippines. No, I'm a Filipino. No, okay. So if you're looking at my YouTube channel, so my YouTube channel is Reggie Marinay. No, study electrical engineering the Filipino way. No, I think I'm the first Filipino will give lectures. No, will deliver a lecture in electrical engineering. No. So our first topic is about electrical principles. Okay, let's start, partner. So please bear with me that I'm not that fluent in speaking this foreign language in English, no. Although Filipino, or although my country is English speaking, our second language is English, no. But we are not that fluent, no. So please bear with us, no. Okay, we have our language, no. We call this as Tagalog, no. But we'll try our best to speak in English so that you may understand our lecture, because we have some foreign friends that are requesting when they saw my YouTube, no, my lectures, no. Are there any English translation here, no? Because he is interested about the topic in electrical engineering. Okay, so let's start. Okay, everybody who is watching in our Zoom class, so please listen carefully. Okay, so we're giving this free lecture on live to everybody. So in exchange for this free lecture, so please listen carefully. No, that is just our request. No, please, everybody listen. No? Okay, so our first topic is about electrical principles. No? Well, here's my name. My name is Engineer Reginaldo N. Marinay. I am a registered electrical engineer. Huh? Okay, so how electricity works? How does it work? No? Okay, first, what is electricity? Electricity is the phenomenon associated with the presence and motion of electrons and other charged particles. No? So if we mean electricity, there is always presence of electrons. Not only electrons, electrons in motion. So there is a movement of electrons, no? And other charged particles, no? So, okay, let us discuss first matter, no? Okay. What is a matter? It is anything that occupies space and has mass. So, do shadow a matter? Is shadow a matter? Shadow. If you're working on the street, there is sunlight, so there is a shadow. My question is a shadow a matter? It's not a matter, no? A shadow is not a matter. no? Because it does not have a space. If we have a space, we have the length, the width, and we have the height, no? It doesn't have a mass, no? So, it's not a matter, okay? Three states. What are the three states of matter? So, we have gas, solid, and liquid. Okay, so we already know these three, no? We have the gas, no? The gas wherein the molecules are widely spread, no? Okay, there is a big distance between each molecule. The solid, no? There is small distance between this molecule and also for the liquid, no? So we have element. What is element? Element is a substance which cannot be reduced to a simpler substance by chemical means, no? So let's say we have the oxygen, no? What is oxygen? We have oxygen as an element, no? This substance cannot be reduced, no? It cannot be reduced. So if that is oxygen, that is hydrogen, no? Those found in our periodic table, no? So that cannot be reduced, no? These elements, no? That cannot be reduced to a simpler substance by chemical means. What is a compound? A chemical combination of elements which cannot be separated by chemical means, but not by physical means, no? Okay. What is the most common compound that you know? The most common compound we know is the water. What is a water? A water, it has two hydrogen atom, no, and one oxygen atom. We can break down these two, no? We have two hydrogen and we have an oxygen. These two elements are necessary for these two elements are necessary for having a water. So we have two hydrogen atom, we have one oxygen atom, and these two elements, we can see these two elements. I have a friend. I remember my friend. Oh, I believe the only thing that I will believe to something that I must see it. You see, there is a saying that to see is to believe. No? To see is to believe. I don't see, I don't believe. I'm just wondering. Look at hydrogen. Do you see hydrogen? No. Hydrogen cannot be seen by our naked eye. I'm quite sad to my friend. He said that before I believe, I must see with my naked eye. To see is to believe. Do you see oxygen? No. I said this to my friend. Do you see hydrogen? He answered no. Do you see oxygen? The answer is no. Oh, so therefore you don't believe with hydrogen and oxygen exist. Oh, he said that he's thinking about that. No? But if you combine two hydrogen and one oxygen atom, you will come up with water. Do you believe with water, my friend? Yes, I believe with water because I see it. Don't you know that water came from hydrogen and oxygen that we don't see by our naked eye? But if you combine the two, you may now see it. I'm just wondering to my friend, do you see your mind? Of course not. You don't have mind. Okay? That's foolishness for me. That's stupidity. No? You don't have to see by your naked eye before you believe. Do you see air? But you believe there is air because you feel it, right? Okay? You feel that there is air, but you don't see that. You see, you don't see some gases, huh? Hydrogen and oxygen. Oxygen is very important in the process of burning. Well, if you have a candle, then you have a cup, no? A water, a glass, then you put the glass on the candle burning, on a burning candle, there will be the fire will cut off. Why? Because this become a vacuum. There is no oxygen present. Because you cover the candle with your glass, with your cup, no? Because there is no oxygen. It's very important, no? That's foolishness. That's stupidity for me. I have to see first before I believe. This is a very common example. Everybody, 2 hydrogen and 1 oxygen. We don't see these 2 by our naked eye. But if you believe with water because you see it, my friend, therefore you must believe with hydrogen and oxygen. Okay, I believe now. Okay? So, you see the point? It's not a good principle that to see is to believe. I don't believe with it. Okay. Now, let's go here. Mixture is a combination of element and compound. Let's say water, we combine it with salt, which is a sodium chloride. That is a mixture. No? You gargle, no? That's a very good to kill the viruses. No? If you already feel that you are itching your throat, no? That's already the sign of COVID. Okay? So, it's better for you to drink water with salt every now and then. Okay? It's a mixture. No? Not chemically combined, but can be separated by physical means. Okay, I want to go back with water. Water can be separated by electrolysis. You can separate hydrogen. Hydrogen is a fuel. Oxygen is very, very important. Oxygen is life. If you have the process of burning, you should have oxygen. There will be no burning if there is no oxygen. No? There is a Filipino inventor. This Filipino inventor, he invents. No? He invented what we call this automotive gadget, no, that separates hydrogen and oxygen. No? If you do that, no, you are the richest person in the world. What do I mean? If you invent a certain gadget other than electrolysis to separate hydrogen and oxygen, other than electrolysis, no, if you invented something so that you may separate hydrogen and oxygen other than electrolysis, you are the richest person in the world. Now, there is a Filipino inventor invented a certain gadget. There is an automobile, no? I think he's a mechanical engineer. There is an automobile being run by water only. You just put the water, there is no gasoline. There is no diesel. Oh. Okay, our Filipino audience, please mute your your Zoom there. Okay? Please mute. What I'm saying, partner? If you separate the water other than electrolysis, you are the richest man in the world. Now, then, there is a Filipino. In the news, well, I watched that in TV. the car is working, no? He said that I already bring this to Department of Science and Technology, but I think they don't believe with it. I already proved to them that my invention is already working. It is working, no? So just put his gadget there, no, in the engine, and then they just put water, no, and the engine works, no, the car moves, no, it travels, no, it works. This vehicle works without any gasoline or diesel. When that Filipino, no, is being interviewed by one of our famous TV personality, he said that I bring this to Department of Science and Technology, but they don't believe with it. I better go to other country. That's a sad thing. You know fluorescent lamp? Don't you know that fluorescent lamp was invented by Agapito Flores? He is a Filipino. He is a Filipino. But he was not honored before by the government. What he did is he go to other country, then other countries finance his invention, no? And the rest is history. It's quite sad, no? So we have many great Filipino inventors, no? But they were not given a chance to be heard by our Department of Science and Technology. So we have here 2 hydrogen atom and 1 oxygen atom. These 2 elements, we cannot see these 2 elements. We don't see it. But if you combine these 2, you can already see it. So for those people who do not believe, who has this principle, no? To see is to believe. Think of it. Think of it. You see this one? No? Okay. So let us continue here. So we have molecule. What is a molecule? Okay, a molecule is a chemical combination of 2 or more atoms. Molecules are the smallest particle that has all the characteristics of a compound. What does it mean? Let's go back again with water. Will you get the smallest particle of a water? Let us get the smallest particle of a water. Let us see here. Let's say that smallest particle of a water is represented by this. Take a look at the figure. So we have here hydrogen nuclei. There are 2 hydrogen nuclei here. Oxygen nucleus. No? Electrons. No? Electron shells. No? The smallest particle of the water is known as the molecule before it breaks down into hydrogen and oxygen. You see? Did you get that? That is a water molecule. That is a molecule. The smallest particle of this compound. Let's say this water. That is what we call molecule. The smallest particle. Okay. Let's talk about atoms. Atoms, the smallest particle of an element. Let's say we have hydrogen, oxygen, no? The smallest particle is what we call the atom. The atom has all the characteristics of an element. You see? Although the atom is the smallest, but it has all the characteristics of an element. I remember, I just forget the English term for our vegetable. You know mustasa? I forgot. Can we do that in Google? Mustasa. Do you know mustasa? Mustasa is the smallest, no, vegetable. But this mustasa, no, represent all the characteristic of that vegetable. You know? Atom has all the characteristic of an element. Meaning, if you have an oxygen element, the smallest part is the atom. No? Okay. How electricity works? Okay. So, take a look at the figure. So, please close up this one. So, we have the atom. Everything in the universe, no? We have atom. Including you is made from atom, no? All of us made from atom, no? How many atom do we have in the universe? How many atom? That is very hard to count. Do you know the largest number invented by men? The largest number is what we call, I hope my spelling is correct. Okay? Google. What is this? That is 1 followed by 100 zeros. It's not billion, it's not trillion. That is Google. I think there is a larger number than Google. That is what we call Googleplex. Googleplex is one Google raised to Google. Wow, that's too many. Okay. The Google, the largest number invented by men or known by men. 1 followed by 100 zeros. No? 1 followed by 100 zeros. You know, a handful of sand that represent a Google. That is already a Google. You want a proof? You count that. You count. If you can count a handful of sand from the beach, that is already a Google. Now, take a look here. No? So we have the atoms. No? We have the protons. Let's say the proton is the red one. We have 2. And then the neutron, we have 2 neutron. No? So basically, at the neutral state, no, of an atom, so they have, or shall we say, in the nucleus, we have protons and neutrons. Later, we will discuss this further, no? Okay? We see here 2 neutrons and 2 protons, no? Then, this is the nucleus, and then this is our orbital shells, no? And we say this one is our valence shell, no? Our valence shell. Okay. Okay? So, let's say, for example, we have a copper atom. Okay? We have a copper atom. We have the 29 here. For copper, so we have 29 protons, no? Will you close up this one? 29 protons, no? 36 neutrons, no? And 29 electrons, of which our free is equal to 1. Okay? What do we mean by free? Free electrons in outer, or that is in valence shell. Take a look here. In copper atom, no? This copper atom, it has 1 valence electron. That is the electron found in the valence shell. No? Okay. The first shell, it has 2 electrons. The second shell, it has 8 electrons. The third shell, it has 18 electrons. And then the fourth shell, it has 1 electron. Huh? That is 1 electron. Okay, now, take a look. Remember that copper has 1 valence electron. Okay. So, this is the copper and this is the insulation. Okay. This is the atomic number 29. No? This is the valence electron. You see this one? There is a valence electron here. Okay, atomic particle. Electron, that is negatively charged particle. The proton is the positively charged particle. The neutron is electrically neutral particle. No? So, neutron, it is not positive, it is not negative, no? That is on a neutral state or a neutral particle, no? Let's have now the mass of a proton. Atomic mass. The mass of proton is approximately 1,836 times the mass of electron. Meaning, the proton is a lot heavier than the electron. Huh? The proton is 1836 times the mass of electron. Where is that? Okay. Let's take a look at the kilogram here. So we have the electron, 9.109 times 10 to the negative 31. That is in kilogram. Take note, it is negative 31. So you have to move the decimal places 31 times, no? Going to the left. Okay? And then this is the mass of the proton. 1.673 times 10 to the negative 27. No? If we are going to divide these two, let us try to divide this using our calculator. Okay, so 1.673, no? The exponent negative 27, and then divided by 9.109 times 10 to the negative 31. It will come up to be, the value is 1,836.645076. Okay, that's approximately 1836. Proton is very heavy, no, with respect to the electron. That is why the electricity is the flow of electrons. Because proton is a lot heavier and electron is a lot lighter than the protons. No? Then we have the charge here. The electron is negative 1.602 times 10 to the negative 19. No? Then the proton is positive. You see, they have the same charge. No? This is positive 1.602 times 10 to the negative 19. So please close up this portion. This is the charge. Okay? They have the same charge, no, in the magnitude, but they have different polarity. The proton is the positive, the electron is negative in charge. The neutron, there is no charge in neutron. Okay, let's go over with the mass again. Electron is 9.109 times 10 to the negative 31. Please close up this portion. Then 1.673 times 10 to the negative 27. This is for proton. And for neutron, no? 1.673 times 10 to the negative 27. So the neutron has the same mass in kilogram, no, to the proton, no? That's why in the nucleus there is protons and neutrons with the same mass, no? And they are a lot heavier than the electrons. Okay. So the next column is the charge to mass ratio, no? Well, you just have to divide, no, the charge into the mass, no? So, atomic number. What is atomic number? Atomic number represents the number of the protons in an atom. So, how many protons in an atom? That is the atomic number. That is also the number of neutron. So take a look here. This is a carbon element. A carbon element has 6. That is the atomic number. Again, what is atomic number? Represents the number of the protons in an atom. Okay. So where is the proton? The proton is the red one. Please focus this one. If you are to count this, 1, 2, 3, 4, 5, 6. There are 6 protons and 1, 2, 3, 4, 5, 6. There are 6 neutrons. No? In the nucleus of an atom. No? So this is a sample of a carbon. This is a carbon element. No? Atomic number, okay, this is 6 as its atomic number. Okay. Let's go over with isotopes. What is isotopes? Isotopes, these are elements having the same number of protons but different number of neutrons. Okay. Before I said, no, basically protons and neutrons, they have equal number. No, equal in number. But if the element is isotopes, no? Isotopes, these are elements having the same number of protons but different number of neutrons. No? Okay? They have the same number of protons but different number of neutrons. Take a look here. We have a carbon here. Okay. The carbon has 6 protons. 1, 2, 3, 4, 5, 6. Then 6 neutrons. 1, 2, 3, 4, 5, 6. Please close up this more. Close up more. Okay. So we have here this one. What about now the carbon 14? No? Elements variants with different numbers of neutrons are called isotopes. Let's take a look here. On the right side, please. This one. Okay. We have a carbon 14. The red one here, 1, 2, 3, 4, 5, 6, represents the number of protons. Huh? But the carbon 14 has 1, 2, 3, 4, 5, 6, 7, 8 neutrons. So 8 plus 6, 14. So that's why it is called as carbon 14. This is a carbon 14. Okay? Okay, so let's go now to the next slide. We have the shells. Huh? We have the shells. Please listen carefully, everybody, because you know I'm already an electrical engineer. But when I study the principles of electricity, I found out that even though I'm already a licensed engineer, there are many principles, no, that I do not know. No, I just discovered last night. Okay, so it's just that everybody is a student. All of us are a student. Okay, so I consider myself as a student of electrical engineering, a continuous student, because learning is a never-ending process. Never stop learning. Always remember that. Shells. Electrons reside in the group of orbits called shell. Okay? There is. I don't know this before. I just discovered this, no, based on my researches, no. I studied electricity in a more deeper way, no. I discovered many things here, no. So, let's say the first shell, we have 1, first, second, no? Okay, so we have number 1 shell, 2, 3, 4, 5, 6, 7. Then we have what we call the K shell, no? There is a letter designation. This is the shell number. We have the K, L, M, N, O, P, Q. Okay. So, this is the shell. Huh? Electrons reside in the group of orbits called shell. These are the shells, no? Just focus the whole PowerPoint. Shell. Shells are arranged in steps that correspond to the fixed energy level. Okay, again. Shells are arranged in steps. Meaning there are steps here. There are shell number 1, 2, 3, 4, 5, 6, 7. No? They are arranged in steps that correspond to the fixed energy, meaning there is energy. What is that energy? We'll take up later. The shell and the number of electrons are predicted by Pauli's exclusion principle. No? Okay? It is Pauli's the one responsible, no, for the shell and number of electrons being predicted. You see, predicted. Why? Because we don't see electron. We do not know, no, that 1 Weber is 1 times 10 to the 8 Maxwells. I'm wondering that our scientists count those magnetic flux. Of course not, because that is just their approximation. 1 Weber is 1 times 10 to the 8, and that is 100 millions plus 9. Huh? Okay, let's go over here. We will take up that later in magnetism. We have the shells of orbital electrons. Take a look here. The shells of orbital electrons. So we have K, L, M, N, O, P, Q. See? This is the first, second, third, fourth, fifth, sixth, and seventh shell. So we have here 2, no? 8. The M is 8 or 18. We have N. We have, this is 8, 18, 32. O, 8 or 18. 8 or 18. And then we have 8 here for Q. No? Okay? What is this formula? 2n squared. The 2n squared is the number of electrons for a particular shell. Let's say, for the first shell, you substitute here 1. So this is 1 squared, simply 1. 1 times 2, so we have 2. That is for the first shell. For the second shell, no? Okay, you substitute 2 here. 2 squared, that is 4. Times 2, so we have here 8. Okay? And then we have here 18. How's that? The third shell. So 3 squared is, what is 3 squared? Okay? Then times 2. 3 squared is 9. Times 2 is 18. Okay? So, well, it depends on the atomic number of a certain element. No? Okay? That you are going to arrange the electrons, no, based on the Bohr model. Again, let's take a look here. Okay, I think we have a picture here for the, we call this one for copper. Okay, the atomic number for copper is 29. Okay, take a look here. That is 29. So, for the first shell, so we have 2 electrons. Then, for the second shell here, is we have 8 electrons. Okay, titingin ka rin dito. Titingin ka rin. The first shell, so we have 2 electrons, no? And then the second shell, so we have 8 electrons, no? So where is that second shell? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 electrons. For the third shell, so we have 18. So where is that 18? This one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then, no? For the fourth shell, so we have 1. If we are to add all of this, so 8, 18, 19, 27, 28, 29. All in all, the number of electrons here is 29. So you will see here, 29. Okay? Did you get that? So that is 29 number of electrons. So this is how they arrange in each orbital shell. No? Okay. This is a little chemistry, no? So let us, this is very important for us to understand the principles of electricity. Okay, so we have this. What is this? So we have a carbon element here. So for carbon, we have 6, no? So in here, so we have 1, 2, 3, 4, 5, 6 protons, 1, 2, 3, 4, 5, 6 neutrons. And then, so we have the electrons. So the electrons, okay, so we have 2 here for the first shell. And then we have here, I think that must be 4, no? 4 electrons. Okay, so we have, what do you call this element? Rutherfordium. Rutherfordium. So that is up to KLMNOPQ. No? So we have, this is the arrangement for the number of electrons. No? If we are to add the 50, let us add this one. So we have 50 plus 32 plus 18 plus 8 plus 2. Okay, so what's the equivalent? This is 110. I think that there must be 4 here, no? Okay, because this is just 100, no? If we are to add 50, 32, 18, 8, and 2, that's 110. It should be 100. Oh, what about that? There should be 104. 104. Okay. Okay. So we have here valence. What is valence? The number of electrons in the outermost shell determines the valence of the atom. No? That is the valence of the atom. The outermost shell is called the valence shell. The electrons residing in the outermost shell is called the valence electrons. No? Again, the electrons residing in the outermost shell is called the valence electron. Why I repeated that? Because the valence electron performs, no? It has a big role in the flow of electricity, the valence electrons. Okay, let's go on the board. Let's say for copper, so we have here, this is the nucleus, no? And then, let's say this is our valence shell. Then there is a valence electron here. There is a valence electron. Take a look here at our figure. So I will draw here a conductor. Then this is the voltage source, positive and negative. No? This is the positive terminal, the longer one. Then we have the negative terminal. We have a switch here. Then we have, let's say, an incandescent bulb. Okay. So this will represent our neutrons, nucleus, I mean. So we have valence shell, nucleus and valence shell, nucleus and valence shell. There you are, no? So we have here our okay. We have our valence electron here. Huh? We have our valence electron. Huh? This one. We have our valence electron. So, please take a look here. When you close the switch, what will happen to this atom? This one. There is a valence electron. If you close the switch, this will impose an electrical pressure on the atom. And this pressure will tend this valence electron to move out of the valence shell. This will move out from the valence shell. This one. Okay? Oh, matatanggal to. No? That will move out. Okay? This valence electron is known as our free electrons. these are free electrons. And this is actually the one flowing. That is electricity. No? This will move, no, from this point to this point. Okay? And then, okay? Again, so there is a valence electron here. If you close the switch, this one, take a look here. Let us start here. Let us start here. If you close the switch, this will move out, no? That will become our free electrons. Okay? And then this will fill up this position and this will vacate, no? And then this will transfer here. This will be vacated, this one, and then there is a free electrons here. Okay? This is a continuous flow of free electrons. And that is our electricity. That is our electricity. Huh? Okay, so let's go over with ionization. Ionization is the process where the atom lose or gain electron. The atom has the capability to lose. It loses electron and it may gain electrons. No? Atoms that gain electrons are called negative ions or anions. Okay? Negative ions or anions. Atoms that loses electrons are called positive ions. Well, of course, if you lose the negative one, you'll become positive, right? Okay? You lose your negative thoughts, you'll become a positive person, right? Okay? That's the parallelism. From time to time, I'll be giving you some parallelism in life. No? That's the difference. No? So, atoms, no? The losses electrons are called positive ions. If you lose the electron, you become positive ion. This particular atom becomes a positive ion, or what we call a cations. No? If you gain electrons, okay, you become anions. So that's why if you meet a negative person, anions. Well, if you meet a positive person, cations. Okay? So, at a neutral state of an atom, the net electric charge is zero, wherein the negative is equal to the positive. The lowest possible energy level. This is the state of every atom. An atom can be a neutral atom, it can be a positive atom, it can be a negative atom. No? Okay? The positive, again, what do you call the positive ion? The positive ion is what we call cations. Cation. The negative ion is called anions. So that it will be easy for you to remember between the two. No? When you take your examination at school or in the licensure exam, no? So that it will not be mixed up in your mind. You see positive? You see the word positive ion, positive. What is that? The question of my professor. It is the positive ion. Is that anions or is that cations? How is that? So that you will not be confused. No? It will be easy for you to answer that examination. The positive ion, cations. What about, sir? This is positive. You have positive in sign, right? Letter T is like a positive sign here. Positive, positive. Did you get that? Will you thumbs up if you get that? Do you hear me? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
To our live audience, so please bear with us, no?
Yes, sir.
We don't have a, they call this a monitor in our studio, no? This is our mini studio, no? Next time, we better have our monitor here, no? For the sound, no? So, we don't know, no? Di natin alam, baka mamaya nawalan na sila ng sound, di natin alam. Mag-chat na lang kayo pagka ano, ha? Wala kaming monitor dito sa sound, kaya ang hirap. Okay, so let's go back to our foreign friends, no? To our kawerpa. What is kawerpa? You are my brothers and sisters in profession, in electrical profession, no? Okay? Whether you are a Filipino or non-Filipino. Okay. Atoms, the lossless electrons are called the positive ions. Okay. This is positive. Positive is plus in sign, right? That is positive. Take a look at letter T. There is no letter T in anions, right? There is letter T. You see, letter T is like positive in sign, positive. So, positive ions, positive. That is cations. That's very easy, right? That's very easy. Okay, now, take a look here. At a neutral state of an atom, no? This is the neutral electrical condition. Okay? They have the same weight here. Okay? They are on the same level. No? Our weighing scale here. Okay. If the negative is greater than the positive, no? Okay? The negative is greater than the positive. No? Of course, that will become a negative. No? A negative atom. No? If the positive is greater than the negative, of course, that will become a positive atom. No? Okay? So, more electrons than protons mean the atom is negatively charged. If you have more electrons than the protons, because proton is positive charge. Just like protons, positive, tons, positive. Electron, of course, is negative. More electrons than protons means the atom is negatively charged. Fewer electrons than proton means the atom is positively charged. No? Because there are more proton, more positive. PP, proton positive. PP, proton positive. Okay? Losing or gaining electron changes the atom's electric charge. Let's take a look again with the atomic model here. No? Niels Bohr invented this model. No? Figure out this atomic model. Actually, there are many atomic model, no, being done by scientists, but this is more popularly known. No? Okay, let's talk about our conductor, insulator, and semiconductor. What is that? What's the difference between the three? Conductor, materials with less than 4 valence electron. So, if you have 1, 2, 3 valence electron, that is conductor. Conductors allow electrical current to flow easily because of more free electrons. Okay, conductor, it conducts electricity or flow of electron. It has less than 4 valence electron. Most conductive elements. So we have the most conductive elements, silver. What is a silver? So this is 63.01 times 10 to the 6. What is S? That is Siemens, no? Or Siemens. The unit of conductance, no, is Siemens. That is an inverted ohm, inverted omega, no? Siemens per meter. For copper, 59.6 times 10 to the 6 Siemens per meter. For gold, so we have 45.2 times 10 to the 6 Siemens per meter. For aluminum, we have 37.8 times 10 to the 6 Siemens per meter. For iron, okay, so we have 10.44 times 10 to the 6 Siemens per meter. As we see here, take a look. The most conductive element here is the silver. But why is that, sir, that copper is being used? No? Because silver is it's very expensive. No? There is, of course, always there is economical factor. No? Although copper, no? We use copper, no, for the transmission, generation, no? And then although what I mean is copper can be mixed up with the other element, no? Just like in ACSR, no? What is ACSR conductor? Aluminum conductor, steel reinforced. So there is steel there. If you have your conductor like this one, that is a stranded conductor. No? So we have, what do we mean by aluminum steel, no, ACSR, that is being used in our transmission distribution line? Aluminum conductor, steel reinforced. What do we mean by this? How many conductors strand do we have? 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5, 6. Then this is 7. The central part is our steel. That is our steel. These are our aluminum conductor. No? I mean, there are copper, no? There are copper-clad aluminum, no? As our conductors, no? Then we also have ACSR, no? Conductor, no? Okay, so we have all of these are aluminum. Then the central conductor is our steel, no? Silver, you know, silver is being used, no? That's the best element being used as a fuse link. Do you know a fuse link? So take a look here. From time to time, we'll be discussing, we'll mix up the theory with practical. No, that's the difference. Okay? So if we have a fuse here, that's very good example is our automotive fuse. No, you see, you know the automotive fuse. It is a transparent fuse. Okay, you will see here the fuse link. Okay, a very good conductor being used in the fuse link is a silver. That is a highly conductive element. No, a silver. Okay, of course, we cannot use gold. That's the most expensive, the gold, no? Okay. Aluminum is being used just like the one I presented you. Aluminum conductor, steel reinforced, no? Okay, so we have our insulator. We have our insulator here, material with more than 4 valence electrons. You see, if we mean insulator, it is, no, more than 4 valence electrons. It can be 5, it can be 6, it can be 7 valence electrons. Insulators will not allow the flow of current because there are less or no free electron. I disagree. But why I put it here? Because this is found in the book. But I disagree here. Insulator will not allow the flow of current. Just this little statement here. Insulators will not allow the flow of current. Let's go over here. I saw some electronic book. In the electronic book, they said that conductor are materials that allows the passage of electricity. Then insulator does not allow the passage of electricity. I disagree with that definition. Why? Why I disagree with that definition? Insulator does not allow the flow of electricity. For me, that's wrong. That is good at a certain level. At a low voltage level, low current level, or low voltage level, that's good. But in the higher study of electrical engineering, it's not good. No? This is a better definition of insulator. Insulator. What is insulator? Insulator, these are materials that allows a few. There is a word few. Konti, small amount. A few passage of free electrons. Okay? So that will be our exact definition of an insulator. Again, please focus this one, partner. What is an insulator? Materials that allows a few passage of free electron, because the one flowing really is the free electron. Is the free electrons. Now, there is a few passage. Again, the definition, no? For me, that's wrong. Insulator does not allow the passage of electrons. That's wrong for me. Why, sir? You ask me why, sir. Hello, guys. Are you still listening?
Yes, sir.
Yes, sir.
What did I say? Okay. We have the materials that allows a few passage of electrons. No? Let us consider a conductor with an insulator. We have a building wire. You see this one? There is a current flow here. Current flowing, a charge flow or an electron flow here. Okay. So, we have here 600 volts. If you increase the voltage, no, this will deteriorate your insulation. If you increase the voltage, there is, always remember, if there is a voltage, there is always a current. A current is the flow of the charge or the flow of these free electrons. These free electrons will tend to concentrate here on the outermost surface of the conductor. There is a tendency for this free electron to move outward the surface of this conductor. This is known as skin effect. Skin effect. What is skin effect? Basically, it has two definitions. Skin effect is the tendency of the electrons or the charges to concentrate at the outer surface of the conductor. That is one definition. Take a look here. There is a tendency, if this is the conductor, the free electrons or charges tend to concentrate on the outer surface of this conductor. That is already skin effect. See here? That is already skin effect. Then, if you increase the voltage and if you increase the frequency also, the tendency is to move outward the surface. If this free electron moves outward the surface, that is skin effect. That is another definition. The phenomenon where the free electron or charges moves outward the surface of the conductor. Going where? Going at the insulation. This is our insulation. Especially when you apply a larger amount of voltage. And always remember this. When current flows, no, there is always generated heat or power dissipation. There is heat generated when current flow here. If you increase the voltage, no, there is a larger amount of current. Even though the voltage is just 230 volts. Okay. No problem because this is 600 volts. There is still effect of skin. There is skin effect. But if you increase the voltage or even larger than 600 volts, there is a larger effect of skin effect. And that is also the flow of electron. It has a tendency to what? To deteriorate the insulation. The current may flow here in the insulation. No? Even though this is an insulator, the current is also capable of flowing through it. Although there's just few, not too many, there's just few. But it is not zero. Because if you say that insulator does not allow the flow of charges or electron, that's wrong definition for me, sad to say. No? Because even though it is an insulator, there is still current flow. I remember we have an owner type Jeep. No, I handle the spark plug. I just handle the rubber portion of the spark plug, the rubber one, holding the spark plug. Nag-ground ako eh. No? I was grounded. No, I was electrocuted, I mean. But I'm just handling the rubber portion. I should not be grounded, right? I should not be electrocuted. Because I'm just handling the rubber portion of that spark plug in the automobile. I'm handling the rubber. It is an insulator. But I was electrocuted. See? It doesn't mean it's an insulator. You will not be electrocuted. That's wrong. That is absolutely wrong. Question, why is that there is a rating here of your voltage? Meaning, if you go higher than the 600 volts, there is a possibility that you can be electrocuted. There is a possibility. Then with some effect of, let's say, a flashover or corona in our insulation, no, we will take up that, no, in the transformer. Okay. So let's go over here. Okay. Now, I think that changes your belief that insulator does not allow the flow of electricity. Mali yun. That's wrong. Hindi porket insulator, hindi dinadaluyan ng kuryente. Even though it is an insulator, the free electron is still capable of flowing through it. But, it's just a little. Konti lang. No? Konti lang. Pero hindi siya zero. Tandaan niyo yan. No? It's not zero. Okay. We have the conductors and insulators, no? Conductors, we have metals, no? We have the copper. Okay, we have the insulator here, no? Okay, let's go over with semiconductor. What is semiconductor? Before I take up semiconductor, I remember my student, no? There is a quiz show, no? There is a quiz show. The question in the quiz show is material that allows a few passage of electrons. A few passage of electrons. Material that allows a few passage of electrons. That is the question in the quiz show. I remember I was one of the judges in our university. And then, the electronics engineering student answered metal. And the electrical engineering student answered we call that a conductor. May I change that? I remember. Will you edit that? A material that allows the flow of electron or charge. No? Okay. Electronics engineering student answered metal. Electrical engineering student answered conductor. No? Okay? Is there any difference between conductor and metal? Okay. That is a tie-breaking question. Whoever answer it correctly will become champion. I remember that. Me, I'm one of the judges. I mistake the answer of electronics engineering student who is a top 1 in the Dean's list, no? Of last semester. First place in the Dean's list. That ECE or Electronics and Communication Engineering student. He said that, Sir, why is that my answer is wrong? Because your answer is metal. The actual answer is conductor. Sir, isn't it that metal is also a conductor? Yes, I said that. Oh, therefore, sir, I am correct. We are correct. Because you said that metal is conductor. But this is my answer. But not all conductors are metal. That is my answer. It's just a matter of how I'm just watching him, looking at his face, how he defends his answer. No? If he defended his answer correctly, I may correct that. But I'm just giving some tricky, tricky shots. Because I don't want them to win. Because I'm an electrical engineer. That is just at the back of my head. Again, what is a material that allows a passage of electron? That is the question. The electronics engineering student answered metal. The electrical engineering student answered conductor. Of course, conductor is the answer. Sir, isn't it that we are also correct? Isn't it, sir, that metal are conductors? Yes. But what I've said is, but not all metals. Okay, all metals are conductor. But not all conductor are metal. How is that, sir? Not all conductors are metal. I just gave him I'm just waiting for him to explain further his answer. I remember lightning. You see lightning? I said that, a lot of electronics engineering clap their hands. Yes, there's again tiebreaker. We have a chance to become champion. Oh. So, lightning. Sir, isn't it that we are also correct? Although our answer is metal. Because all metals are conductor. But I said, but not all conductors are metal. Example. I gave example. This is what I've said to him. Remember, he is the top 1 in the Dean's list of the previous semester. Example, lightning strike. Do lightning is the flow of electricity? Yes, sir. He answered that right away. Question, where is that lightning flows? It flows where? It flows on air. Prove to me that air is metal. Air is conductor because the lightning strike flows in the air. Therefore, the air is a conductor. Now, prove to me that air is conductor. He answered nothing to me. He is just thinking. Maybe that time, if there is Google, he will do that. Huh? Prove to me. Prove to me that your answer metal only is correct. But because the answer is conductor. Huh? The only answer is conductor. You will not see electrical book, insulator, semiconductor, then metal. There's no book. There's no book. Electrical book. You can show that to me. Water. I gave him another example. Water. Do electricity or electrons can flow in water? Yes, sir. Is water a metal? Prove to me. I said that to that student. You know, guys, water is an insulator at its purest state. You try a distilled water. It is a pure water. It's an insulator. So it becomes a conductor when? You can answer me. You can answer me. That's why I disregard. I remember the board of judges is an electronics engineering professor. Because, of course, at the back of his head, he wants to, his team wants to become, he wants his team to become a champion. But I disagree with the answer. All of the students and judges are looking at me. Pambihira naman, oh. Kala ko tama na kami, oh. Yung mga ECE professor nakatingin sa akin, masama na tingin sa akin, eh. You know your logic? What about, sir? You know your logic? Jonas swims. Jonas swims. The fish swims also. You know swimming? Fish swims. Jonas is a person, swims. Therefore, Jonas is a fish. You see the logic? Not all living things swims. Not all living things who swims is a fish. Because there are humans who swims. You see? What is a good example? You have the biogesic, the tempra, the calpol. All of them are paracetamol. But not all paracetamol are biogesic. Did you get that? Will you thumbs up if you are getting my my point here? I want to see the audience. Because that is your logic. Your answer is metal. Are you getting me? I want them to show in the Facebook Live also, no? So that the one watching in Facebook Live, no, they will see that we have a live audience here. You see, we are not yet in Ohm's law. You know, we are breaking down these topics, no? You know, in a very detailed way, you know, in a deeper manner. That's what we are doing here right now. That is the difference, no? Okay. Eh, sabi mo ba naman, metal eh. No? Minali kita. No? Si Jonas ay lumalangoy. Yung tilapia ay lumalangoy. Therefore, si Jonas ay tilapia. No? Galit na galit sa akin yung mga estudyante. No? Oo. Sanay na ako ng mga naiinis sa akin eh. No? Sanay na ako nun eh. No? Pero, pamalian nyo ako bago kayo mainis sa akin. No? Pamalian nyo ako. Yung totoo lang sa puso nyo, pamalian nyo. No? Kung mapapamalian nyo. No? Okay. Let's go over with semiconductor. Semiconductor, materials with exactly 4 valence electron. No? So, therefore, the reference is 4. If you go less than, this is a conductor. If you go higher than 4, it is an insulator. Semiconductors have electrical characteristics between conductor and insulator. So meaning, no, just like a diode, no, silicon, germanium, no, these are some element, no, these are semiconductor elements, no. Okay, so meaning a semiconductor, no, it can be a conductor, it can be an insulator. It can perform the two functions, no. Just like a diode, no? Well, we'll go that if we go to electronics. We have a subject electronics, no? So, being taught by my friend as an electronic engineer, no? A diode, forward bias when it conducts, no? That is a conductor. Let's go over here. I'll give a little example. Semiconductor, okay. The first solid-state device being used in electronics is a diode. That one. A diode. This is the positive, this is the negative. The forward bias, okay, if we have a switch represented by closed switch, this is the forward bias. The forward bias, this is a forward bias, meaning the semiconductor acts as a conductor. It acts as a conductor. This diode, no? Okay? Take a look. This is a conductor or forward bias if the current is flowing in this direction. This is the key. If you see this one, this is an arrow, same direction as here, that is going to the right, same direction that is forward bias. This is the conductor. Now, this is going to the right, no? And this is going to the left. So, therefore, that is reverse bias. No? Take a look here. This is open switch. So, this is the reverse bias represented by an open switch. So, this is the time when this semiconductor acts as an insulator. This is an insulator. Okay? Okay, so let's have the valence band. The region where the valence shell and valence electron are occupying. No? So this is the valence band. So we have the valence shell. That is the outermost shell. No? And the valence electrons occupying. There is a place, there is a space being occupied. That is a valence band. It is the highest energy level before the conduction band. Okay. What about the valence band, no? The highest energy level. Conduction band. What is a conduction band? The region where the free electron is said to be present. Electrons at this band have a high energy level. No? In the conduction band, high energy level. The conduction band, again, that is the region where free electron. We said that electricity is the flow of free electrons. As the free electron flows, it flows in the conduction band. No? That's what you call conduction band. Just like NLEX, SLEX. It is a place. It is a conduction band. No? The region where the free electron is present or flowing. Electrons at this band have a high energy level than those electrons at the valence band. Okay. Very high energy level, no, present in the conduction band. Forbidden band. The region in an atom where no electron exists. Okay, because that is forbidden. From the word forbidden, meaning there non-existence, meaning it is between two allowed bands, such as between valence and conduction band. Energy gap, no? Okay. So, what do you mean by energy gap? No? This is Milo, no? Commercial. Okay? Energy gap. So, what is energy gap? The energy difference between the valence band and the conduction band. Okay? Again, the valence band is the region where the valence electrons are located. Wherein it is found in the valence shell, right? The conduction band, it is also a region where your free electron, because all free electrons are valence electron, right? What is the difference? Free electron are valence electron that moves out of the valence shell. Remember that. You are no longer connected to the valence shell. The unit is electron volt. That is what we call the energy gap. Again, energy gap is the energy difference between the valence band and the conduction band. So, there is a difference between valence band and the conduction band. Let's say this is the valence band, this is the conduction band. There is an energy gap here. No? The unit is electron volt. Conductors, 0 electron volt. Insulators, greater than 5 electron volt. Semiconductor, that is equivalent to 1 electron volt. Okay, so this is energy band diagram. This is the energy band diagram. You know, from the figure, let's go over here, partner. This is the nucleus. There is orbital shells, no? You see, to figure out this energy level, it's like this one, no? If you are to figure out the energy level, okay, so this is how I figure out this one. It's like a right triangle. From the nucleus going to the valence shell, there is a large amount of energy. No? You see, take a look here. There is a large amount of energy here. Okay? So take a look here. From the nucleus, no? From the nucleus, the ground state, so we have the energy band. We have energy band, then we have first energy level on the next shell or first shell, no? First shell, second, third, these are the energy levels. And then we go now to the valence band. Okay, let's go over here. If we have here the valence electron, take a look here. This is the valence electron, this one. Okay, again, once we close the switch, just like our example earlier, this valence electron will move out. Okay? Will move out. And this is known already as the free electrons. Free electrons. Now, take a look here. The valence band here, there is forbidden band, there is conduction band. Where is that here? Okay, I'll show this to you. Where is the valence band? The valence band, no? It is the energy, no? That is why your valence electron is connected here because there is a valence band here. There is a valence band. And this is when this valence electron moves out, so there is a conduction band here on this area. Okay. What about the area that is not located? There is a valence band here. There is a valence band here. There is a conduction band. But in between the valence band and the conduction band, what do you call this portion? No? This is what we call the forbidden band. Forbidden band, no? Okay? Again, what is forbidden band? No? The region in an atom where no electrons exist. No? That's the difference. You see, take a look here. From the nucleus going to the conduction band, there is an increasing energy level. Okay? Wherein the maximum energy is found in the conduction band. Wherein your free electrons moves. Okay? There you are. These are the band gaps, no, between these conductors, no. So we have silicon 1.11 electron volt, germanium 0.67 electron volt, silicon carbide 2.86 electron volt, aluminum phosphide is 2.45 electron volt, gallium arsenide 1.43 electron volt, indium phosphide 1.35 electron volt, no? Okay. So, let us go over with electrostatics. Okay. We already discussed the charges, no? So we can have now a positive and negative charge, no? So electrostatic deals with the phenomena due to the attraction and repulsion of electric charges that are not moving. They have there is a force of attraction. No, we have a separate topic for this, no? We'll discuss this into detail, no? That is the second part of direct current circuits, no? But I'll give you a little background, no? So, it deals with the phenomenon due to the attraction or repulsion of electric charges that are not moving. So, charges that are not moving, let's say positive, negative, negative, positive, negative, negative, positive, positive, no? So, there is a forces of attraction or repulsion between them. You see? Okay? What can you say? This was introduced, no, by Charles Coulomb, no? Positive, negative, attract. Okay? You see the nature of charged bodies. Electron charge, negative 1.6 times 10 to the negative 19. Proton is positive 1.6 times 10 to the negative 19 Coulomb. Like charges repel each other, opposite charges attract. You see? Like charges repel. No? Positive, negative, attract. No? Positive, negative, they attract. Positive, positive, repel. Negative, negative, repel. No? Just like in human being. No? Just like in human. No? Okay. Boy, girl, they attract. Okay? Boy, girl, attract. Girl, girl, repel. No? Boy, boy, sometimes attract. Okay? So, of course, it must be repelled. Okay? So, now, well, no? I think I don't have the luxury of time, no? So, we will continue this tomorrow, no? For our part 2 of our electrical principles, no? May I entertain maybe around 2 to 3 questions, no? If there are. So, please type your questions, students, no? Based on your I want to see the students. Okay, students, when you type your question based on the topic I discussed, no? This is just the first topic. Okay, any question? Will you type your question? If there are, let's take a look at the chat board. Oh, there's no question here. Please type your question in English, please. For our non-Filipino audience, our friends, no? Just in case, no, we have our friends from America, from Asia, of course, we are here on Asia, from Europe. Okay, any question? You don't have question? Any question? Who has a question who would like to ask question on, because no one is typing his question, on a live question, may I see? Will you raise your hand? Please speak in English. Any question? If you have any question, please raise your hand, please. Let's go on the first slide of audience. First slide, please. Are there any questions? Okay, second slide, please. No question here. Please raise your hand if you have any question. Next slide. Do you have only 2 slides? No question? Okay, please type your question if you have any question. Okay, if there are no question, so that's the, I think we are not seeing any question for the first topic. Okay, is my discussion, did you get my discussion? Okay, is that clear? Is that clear?
Yes, sir.
Yes, sir.
Do you have any question? Billy, do you have any question? Please speak in English.
Nothing, sir. It's all clear. And I
Okay,
understand all.
okay. If you don't have a question, can you give your comment in our lecture for today, in our lesson for today? No, can you give some little comment?
Yes, sir. Yes, sir.
Any comment about our lesson?
Please, sir.
Yes. You want to say something or anything about our lesson for today?
Okay, sir. Our you discussed already about the topic today. I also understand. And, uh,
Is it clear with you? Is it clear with you?
sir.
My discussion? Is that clear?
Yes, sir.
Okay. Can we have other comments? Other students who would like to... Okay, Janelle, can I get some comment with you? Just a little. Can you speak with your microphone?
The webinar
Please
is
speak in English. Please speak in English.
your
Please,
lecture
please
is
speak
very
louder. That's
informative.
It's unclear, so please make it clear. Please speak louder.
Your lecture, sir, is very clear and informative, sir.
Okay, that's very clear and informative. Is that what you said?
Yes,
Okay.
sir.
What else? One more, one more. From PUP, Jomer. Jomer, any question or comment with our lecture for today? Siya ba yung sira? Yung sa, sounds niya? Let's see other student. Adrian from PUP Taguig. Any comment about our lecture for today?
Sir, it is delivered well, sir.
What? Again, please repeat.
The lecture is delivered well.
Okay. Thank you, thank you. Okay, so if there are no more questions, so we will leave now to our Facebook friends, no? So, okay, thank you very much to everybody, no? So, to those students in our Zoom classroom, so please stay there, no? Do not leave, no? And then for our Facebook participants, so thank you very much. No, you can, I'm encouraging you to join with our pre-webinar. This is already part of our pre-webinar. No, we've been doing this no since June of this year. No, so to be exact, June 17 was our first day of giving a pre-lecture, and you may see our lecture on YouTube. No, please subscribe, like, share, and comment. No, our YouTube channel and our some posts in our Facebook. No, that is a Marina's Powerhouse Facebook account. Okay, to our non-Filipino audience. So this is the beginning, no? This is just the start of the first topic about restudy electrical engineering. No, maybe we can do something to help you guys, no, and to improve you and to enhance you more, no, in your learning, no. So we'll see to it that we can add something to your knowledge, no. So just stay there and thank you very much and keep safe. God bless you all.